Unit 4, so we are going beyond CPCTC. So something you may be asked to demonstrate or prove is that two lines are parallel to one another. In order to do that, we need to demonstrate one of our angle relationships, and often the angle relationship that we're going to show is alternate interior angles are congruent. Because if the alternate interior angles are congruent, then the two lines cut by a transversal are parallel. So converse theorem would be the converse of alternate interior angle theorem. So if alternate interior angles are congruent, if we can show that, then the two lines cut by a transversal are parallel. Okay, so if the alternate interior angles are congruent, then the two lines are parallel. And you can have converse corresponding angle theorem, converse consecutive interior angle theorem. It depends on what you see and what you're given. Most of the time, it will be the converse alternate interior angle theorem. And again, if you don't remember what the name of that is, then you just have to state what it says. Right? Again, the name is not as important as knowing what it means and what you need. Okay, so let's look at this diagram. If we were to prove this angle congruent to this angle, which are alternate interior angles, so if we show angle 1 congruent to angle 2, that is going to show that CD is parallel to AB. If we were to show that angle 3 is congruent to angle 4, which are again alternate interior angles, then that would show that AD is parallel to CB. And again, the alternate interior angles are formed by that transversal intersecting those parallel lines. So between the transversal and the parallel lines, that is where that angle is. The reason that angle 2 won't prove alternate interior angles, because notice 2 does not extend all the way to the parallel line of AD and BC. So angle 2 would not be an alternate interior angle for AD and BC. However, it is an alternate interior angle for CD and AB, because angle 2 does lie in between the transversal and the parallel lines.